Alright, so partition to k equals some subsets. This is a good problem. We're given nums and k is equal to some value. So we are asked if we can divide the nums array completely in groups of four. I mean, in four groups where the elements in the group sum up to some equal value. All of them must sum to an equal value. So this starting off gives us intuition that this summing up to an equal value can be only one target value, and that can be calculated using this formula, simple formula. With this first example itself, this part should be clear. Suppose this is example, k is equal to 4. So if you want four groups, then the target sum can be only the total sum. That's nothing but 4 plus 3 is 10 plus 4 plus 5 plus 1, right? This is nothing but 20. So 20, that's the total sum divided by 4. This is what the target is, that's 5. So each group, if we can form a group or four groups which sum to 5, that's the question. And how can we do that? Is there a greedy way? If you try to think of it, you won't find any greedy way in that case. But that greedy way, if you try to solve that mentally, will lead you to a DP solution, which is nothing but I try to form every group that is possible. So if I take 4, I can take a 3, but that will lead to a target which is negative, right? Or negative if you keep subtracting, otherwise that will be a greater target. So right away here, this will return false, this will return false, this will return false, but 1 will return true because we'll end up having the target value, that is 5. So right now I have used this, I'll mark it as this, and I have used this. So I am not going to use it again. So now I'll traverse the array. I'll traverse the entire array because I don't know which element I have used or not. So right from the start again, I'll traverse. Now I can't choose 4, I can choose 3. If I choose 3, my next target will be 2. I need 2 because 5 minus 3 is 2. I can choose 2 here. Now I cannot choose 2 again. So I've marked it. And now again I'll start. So right now I'll also keep on, as long as I keep reaching to the target, I'll keep on subtracting k. So as of now I have gotten two groups, 4 1 and 3 2. So now my k is 2. So I need two more groups. I traverse the entire array. I reach here because all the other ones I used. 3, I see 3. Now my target is 2. I see 5, that's not good. I see 2, that's good. So I have reached another target. I'll subtract k and I'll use up. I'll mark this element. Now again I'll traverse. Finally I'll see that 5 is what I need. I'll mark this. So right now, because all the elements are marked, which means I've used all the elements of the array, and my k is equal to 0 because the last element was 5, and that is a group in itself, and that's why, because this and this is true, I'll return true. So this is how we are going to solve this using DP. Alright, so let's start coding. We are going to traverse the array again and again. So there's going to be a loop in the DP. And before the DP itself, we need the target value that can be stored in a target variable. This target variable is going to be initially 0. I'll traverse the array, get the entire total sum of nums, and I'm going to increase the target by n. At the end, if target is going to be target by equal to k. But what if target is not divisible by k itself? It's a floating value, decimal value. In that case, for example, this sums up to 10, but 10 is not divisible by 3, so there itself we should return false, right? So before dividing, I'll check if target is divisible by 3. If it's not, then return false here itself. Alright, now I'll also need something to keep track of which element has been used. Alright, so now this can go in different ways. How can I do that? I can have a vector, right? A vector of index. For now, let's have a vector of index, which is nothing but if it's visited or not. The size is going to be nums of size. Its initial values is 0, and I'm going to return solve, and this is nothing but it will have nums. It will have index, which is 0 first. It will have k, how many groups left. It will have target. It will have visited. Right, so boolean solve vector of nums. It will have index. It will have k, target, visited. If the safe condition or the one that is valid entirely, so at this point I should return true. What is that condition? If all of them has been visited, and if k is equal to 0. So k is equal to 0. If it is, then it's pretty straightforward to check that. But visited, how will we check that? The only way to check that is traverse the entire visited array, which is doable because given that it's only 16 in terms of length, so you can do that. Or probably if there's a better way also, I can take a map instead. Alright, this is going to be a map as well. No size needed. Right, I can, instead of visited, I'll call this map. I will increase or keep count of all the variables. Alright, and I'll pass this map into this, and I'll check if the map right now is empty. If it is, that means that I have used up all the elements and it's safe to return true. At this point, I'll check if index is greater than equal to nums of size or k target is less than 0, or if this element is, or actually let me not check it here. These are the two things. Return false here itself. Now it reverse all the elements of the array. So if this element has been used, which means if map dot find will not have something of nums of I into it, in that case I should continue. Otherwise I will reduce this in frequency, reduce its frequency if np of nums of I is equal to 0, which means it's good to remove this element so that I can, safely check if size is getting reduced or not. Alright, so erase. At this point, I will check for two conditions. The one condition is the target, right? If target minus nums of I, if it's equal to 0, in that case, I have found a group, which means it's time to reduce k. So I'll solve. So solve will return something. I'll accumulate it in a variable. For now, let's focus on the recurrence relation. So I'll increase the index for sure. I have already marked this index using map, so it's good. What is the second? Third variable is target, or actually k. Third variable is k. I will reduce the group. I will change the target to the original target, right? Whatever the target was, but I have not stored anywhere, and this state I'm changing constantly. So I create a fixed target, which will be initialized here as target. All right, I will pass fixed here, and I will pass map. Right, that's variable. Otherwise, I have not found the group, but I have found an element. So I'll reduce the target. I'll increase the index. I'll not change the group. I will reduce the target by nums of I, and I will pass the map as it is. Alright, I will have a boolean answer. which is initially false. This is going to accumulate inside answer as OR precondition. Answer as OR operation. I'm going to return answer. I am missing something because I am not doing a backtracking on the visited or the map that I'm changing here, because I need all the combination. I need to do the backtracking for this state because it's not going to change inside the state, right? This is changing outside the state. So I'll make sure that I will increase nums of I again during my backtracking. Let's see if this works. Alright, nums is needed. When this works, it's time to memoize. Now comes some interesting part. Am I even using index anywhere? I actually don't need this because I'm always inbounds, so I don't even need this index, do I? I don't need this because every time I'm passing this, every time I'm passing every element, I'm checking if it's valid or not. And let's see. By the way, I should remove this as well. Alright, let's see. Without one state, now it's easier to memoize. Okay, this works. But if you think of it, there are three states. This is easy to memoize. This is easy to memoize. This is changing from, it's varying from 1 to k. The target is varying from 1 to total sum by k. But map is also varying. And it's not easy to memoize map. So we have to find some alternative. Now, if you think, if you look at the constraint, nums.length is just 16. So this is a hint in itself that we can memoize it based on the index, if that index has been used or not. And if we use bit masking because it's just 16, then I can just have an int variable here, and integer is very easy to memoize it. So what I'm going to do is I'm going to have a visited, which is initially going to have 0 value. So I don't need map now. I'll remove every instance of it from the code. I'll pass visited here. I'll pass visited here. So if my visited is initially 0, which means that this is, or let me do it on a smaller example. This is my visited initially. I use this, so I make this 1. Alright. If I use this, suppose I use this is just an example. So I use this, I make this 1. So by the end, if I have used all the elements, then what will I check? If this is equal to visited, in that case, I have utilized everything. So the alternative for this point will be if visited is equal to all ones, right? For nums.size, that's what we need. So if we look at, suppose example is 15, which is all ones for this particular example. This is going to be the base case. This is nothing but nums of size, which is 2 power 4. Is it? Yeah, 2 power 4. Nums 2 power nums dot size minus 1. This is what is going to be the base condition. If it's equal to visited, then it's good to return true. I mean, in combination with k equal to 0. So at this point, I will have something like 2 to the power nums dot size minus 1. If this is equal to visited, then it's good to return true. Yeah. So now comes the marking part. How will I mark? Or how will I check first if it's valid or not? If it's not used up or not. So if this current index is used up, which means if visited is reduced down to the first bit, and if I do AND on it and I get a 1, in that case it's been used up. Alright, so this is straightforward. At this point I just need to mark visited at this particular index, right? So if visited is equal to visited or 1 this particular index. If I do OR, then I'll be changing the visited bit at that position, which is what I want. And finally, clear it. Clear the bit. So clearing is nothing but doing a AND operation, right? With a 0. So this is what I need, but I need the complement of it. So I'll do this. So this is the complement. This will clear the bit that I want. So that's what we need during backtracking. And I think we are good. Let's see if this works. Then we'll minimize it. It works. This will also give me, TLE. So I need a 3D vector. Alright, this is nothing but cache. What's going to be the size? K is going to vary from 1 to K. So K plus 1 vector of int. Alright, target is going to vary from what? Uh, from the total sum, right? That's what it's going to vary. So target plus 1. I should keep this here. Target plus 1. Finally, uh, last index will be visited. So visited is going to be this 1 lesser than nums dot size minus 1. This is what visited is going to be, and that's nothing but 2 to the power 16. Let me do it this way itself. Minus 1 comma minus 1. So this is what I initialize it. By the way, there's a better way to use a map. But yeah, let's use a map. I think it's better. Unordered map. Finally, another unordered map. Cache. Let me pass the cache here. I will pass this as an argument in my function as a reference. I'll call this cache. If cache of key, uh, if cache has a key, and if cache has a cache of k has a target, and similarly cache of k and target has a visited. Dot end. Alright, at this point return cache of k, target, and visited. Alright, so at this point I will initialize it with the answer value, and let's see if this works. I'll pass cache here. I'll pass cache here. Let's see if this works. Alright, there should be a semicolon. There might be other mistakes. I know it. Cache dot find of k, cache dot end, cache of k dot find target, cache k dot end, cache k target dot find visited. Alright, let's see. Alright, there is an extra brace. Let's see if this works. It does. I think this should pass. If we talk about the time complexity, then this is a minimized solution. So we should focus on the states and its how it is varying from what to what. So k is varying from 1 to k. So there is going to be a k in my state. target. Target is varying from uh, 1 to target basically, because I'm not going to not going less than 0. So or 0 to target. What is target by the way? Target is total sum by k. It's not going to be a constant. Total sum is going to be a constant. K is also going to be a constant by the way. So it's eventually going to be a constant. Uh, so I need not worry about it inside this, because the third variable is the third state that is varying is visited. Visited is varying from 2 to the power n essentially. So this is going to be my time complexity, and my space complexity is going to be what is going to be O of n, or actually it's going to be 2 to the power n, because that's what uh, is dominating in visited. So it's going to be 2 to the power. So yeah, that's the problem. Thanks guys.